Okay, so I'm going to continue on in wiring methods here. So they start, now we're going to be sizing boxes. So we size conduit, now we're going to be sizing boxes. And we got a scenario where we're smaller than number 4, AWG, and then we'll deal with the number 4 and larger coming up. So first couple things it talks about is going to table 23. So we'll go check that out here in a sec. And that's where we're going to find all our lists of box sizes, but also how to count the conductors so that we know which box size we're going to use. So we'll start with these rules here, and then we'll go to table 23 and see what's it's all about. So in this scenario here, again, I'll flash back here to the color one. It's a little easier. But just so you guys know where I'm referencing this as I'm reading them through when I show you that other picture. Okay, so I'm just going to bring up this, hopefully this picture here. Okay, so this is the same picture here, it's just in color, so it does help out quite a bit, I find. So the first one says, one unspliced conductor passes through the box. So that's this black one here. Okay, and it says read 123034 1A. Basically said an insulated conductor running through a box with no connection therein shall be considered as one insulated conductor. Okay, and we're only counting insulated conductors. So if you got BX or Lumex or NMD90, going through with bare conductors, we don't count those at all, okay, because this rule is based on insulated conductors. So again, the first one, that black one. Next one says, each insulated conductor entering or leaving a box and connected to a terminal connector within the box shall be considered as one insulated conductor. So again, entering or leaving. So let's call these the entering, these the leaving, and connected to a connector. So the red, white, and blue. So 1, 2, 3, 4, 5, 6. So we got 6 conductors we're counting based on the entering and leaving, or subrule B. C says an insulated conductor of which no part leave the box shall not be counted. So these wires here, they're not leaving the box. I mean, technically, right now they look it because we got it pulled apart, but when this is on here on this Taylor cover and we push it in, it's sitting, these wires are in there, but they're not leaving the box. They're not going in that conduit or in that conduit. So we don't count these wires. Okay, that's what C's in. So then it goes to subrule 2, and it says the 3 wire connectors. Okay, so we're going to deal with these now, these wire connectors, wire nuts, morettes, whatever you want to call them. And basically says that we're going to count some wires for other things taking up space, including these wire connectors. So it says, 2B says, one insulated conductor for every pair of conductor connectors with insulating caps. So for every 2 morettes, or wire connectors, we're going to give it 1 insulated conductor. So there's 3 here, so we're going to add 1 more insulated conductor because of these 3 morettes. Okay, again, if there was 4, it would be 2 because it's for every 2, but in this case it's not. There's only 3, so this guy's left on his own. This pair gets 1 insulated conductor. Then the other thing we want to talk about in this subrule is we have 2 insulated conductor counts if the box contains 1 or more flush devices. So in this case we do have this switch that's going to be flush mounted, so we count 2 conductors for that. So if we go back to the module here, I'll just zoom in to this. So that's kind of what they got as this tally here, okay, is we got 1 conductor going through, 6 conductors, they're the ones that are spliced, so entering or leaving. Conductors to the switch are not counted. The 3 wire conductors are counted as 1 conductor, and the switch is 2, based on these rules. So in total, we have 10 conductors that we need to count. Now, if we go to table 23, like it told us to, we're going to find what size of box can we use for this scenario. So I got 10 number 12s here. So table 23 is laid out per wire or by milliliter. Okay, we're looking at this section here because we have all the same conductor. So we have 10 number 12. So basically I'd go down here and say What can I use? Well, I can't use this box because it's only good for 8, but I could use that box because it's good for 12. Okay, if they're all square boxes, you basically use any one of them. Okay, so that's how we're going to find out the size. Again, it would be nice if they narrowed it down. Is it an octagon? Is it a square? Is it a device box? Okay, and then we could find out which one we could use. The second scenario they're going to talk about in our module is if we have conductors of different sizes. Okay, so in this case, we have two number 14s being spliced on each other, and we have a three-wire circuit, so 3 wires coming in and 3 wires leaving and being spliced for our number 8s. So we count them up just like we did. We got 1, 2 entering, 1, 2 leaving, so that's 4 wires. 2 morettes gives us 1 more insulated conductor, so for a total of 5 number 14s. So 4 wires, 1 for the moret. 6 wires here, 1, 2, 3, 4, 5, 6, and 1 wire for the morettes. Again, there's 3 of them, but only count a conductor for every 2 morettes, okay, or wire conductors. Then basically once we get our total, so there's our 5 and our 7, so 5 number 14s, 7 number 8s, we got to get to this other table. So table 22 is going to show us the milliliter size for each conductor. So for a 14 is 24.6, and for an 8 it's 45.1. So go back to this and say our 14's at 24.6, we times that by 5 because there's 5 of them, and we times that 45.1 times 7 because they were 7 number 8's, and we get our total. Okay, some of our questions, that's just what they're going to ask for is the total. Now 23, if we want to find a box, okay, and this example here says looking at square boxes, so let's look at the square boxes. Again, that milliliter of 438.7. Under square boxes, this is what we're looking at now is the milliliters, okay? And we had 438.7. So we can't use this box. We could use this one, or this one. So out of the 4 boxes, we could use these bigger 3, but not that one, okay? Because it wouldn't fit based on our calculated milliliters. So that's how you use 22 and 23 together. Now, boxes for conductors, number 4 or larger. Got a little bit of a different scenario. First thing we got to watch is if we have a piece of tech coming in. So basically we're going to start using the diameter of the conduits for these larger sizes. So if we have a piece of tech coming in, like this example here, we have to turn that into an equivalent conduit before we start doing calculations. So it tells us how to do that right here. So it tells us to go to look at the wire size for the tech. So if it's number 250 kc mil, we still go to 10A to find out what the area is of those cables. And then a little thing we haven't talked about here yet is table D5. Okay, and that's going to tell us how to do that bare stranded conductor. Okay, and it's in the appendix, so that's where it tells you to go to D5. So just go to that rule and go to the appendix and it'll show it to you. And then I'm going to get to table D5 here and see exactly, well first here I'll show you what it says. Dang, that was bright. This is where it's telling us to go to table D5. Okay, so under rule 12.9.10, flipping over here, and at the bottom it's telling us to go to D5 for that measurement for that stranded. So I'm going to go to table D5 just so we can see where they got that number for in the mod, so that we have an understanding. So again, here's D5 here, strandings for building insulated conductors or cables, standard, flexible, extra flexible. We're under standard 7 strand, and in this question it's telling us we're number 4. Okay, standard 7 strand, so we go to number 4 and we're going across, and occupied area we're going to get 28. Okay, so that's where they're getting this 28 from here. This value here, this 288.5 times 4, that's from 10A. Okay, so no different than when we were sizing conduit for that. Then we add them together. Now here's the sticky part with this, is to find the conduit now. We still go to table 8 to get our fill, which in this case we have more than 4 conductors, so I know that's a 40% fill. Then what we got to do is go find a conduit that would fit based on that calculation. Okay, so this calculation of 1182. So which conduit should I be checking? Well, unfortunately, we got to check them all. Okay, to find the smallest. Going in the 40%, again, because of table 8, because I got more than 4 conductors. And I'm just going to scroll down until I see, again, I'm looking for 1182, or the conduit that would fit it. So I can use a 63 out of this 9A, 9B, go down, also a 63, and continue to go through. Okay, we will find out in this case that a 63 is the smallest that we get on any table. So the equivalent conduit for this cable is a 63 millimeter conduit. Okay, and again, we might need to know that to do a calculation. So they go through the different scenarios here of the number 4 or larger. Just going back to the rule 12, 30, 36. So this is where they're starting talking about pull box or junction box sizes. Again, first rule says we have to have the equivalent cable or trade size raceway, okay, based on the minimum required conduit for the cables that are in the, or conductors that are in the cable. Okay, so just what we were just talking about. So where a pull box or junction box is used with raceways containing insulated conductors of number 4 or larger, box shall. So for a raceway entering the wall opposite of a removable cover, so in the back, have a distance from the wall to the cover not less than the tray diameter of the largest raceway or equivalent cable plus 6 times the diameter of the largest insulated conductor. So that's this scenario they're talking about here first. So coming in the back, again, opposite the wall of the cover, removable cover, and this is how we're going to go through and size this box. So again, this is the dimension we're looking for, because you got to think we're pulling through this way or this way, and we got to make a bend and be able to feed it through the back. We've got to make sure our box is deep enough to take that bend. Okay. So the larger conduit, again, in this is a 53, right? 53 trade size containing 3 250s. The smaller is a 27 with 3 number 3s. The depth of the box is the diameter of the largest raceway plus 6 times the diameter of the largest conductor. So watch that, because when we did our 10A before, we went to the area when we were doing conduit fill. Here we're doing diameter, okay, to do this calculation. So just watch that when you go to table 10A, it's a different column, okay, and follow this and you'll go see exactly what I'm talking about. So we take the diameter of the largest raceway, so in this case a 53, plus 6 times the diameter. Again, this 19.17 is from the diameter column on table 10A, not the area, the millimeter squared. 6 times that, we get our total. That's the minimum depth that box has to be. Okay? When they pass straight through, what does it say about that? For straight pulls of runs of cable have a length of at least 8 times the trade diameter of the largest raceway or equivalent cable. Okay, so if that's 53 times 8, that's how we'll get this length right here. And then the last scenario they talk about is the U-pull. So an angle or a U-pull, okay, have a distance between each raceway or cable entry inside the box and the opposite wall of the box. Okay, so just before we get too far, from where they enter, we're looking for the distance from where they enter to the opposite wall. So for these conduits, we're finding out this length right here, this side B. Okay, and it says 6 times the trade diameter of the largest raceway or equivalent cable plus the sum of the trade diameters of all other raceways on the same side. So to find B, we're going to go 6 times the largest, so 6 times 63 plus 41. So that's how we get this number right here, this 419. On this side, again, 6 times the largest plus the other sizes in the on the same side. So in this one, 6 times 63 again, but plus 35 plus 21, and that's how we get side A. C and D aren't too terrible to go through. Basically, have a distance measured in a straight line, okay, between the nearest edges of the raceway or cable entry enclosing the same insulated conductor of at least A, 6 times the trade diameter of the raceway or equivalent cable, or 6 times the trade diameter of the largest if they're different. Okay, so to find C, we're just going to take the 63 because they're the same, and we go 63 times 6. For D, they're different sizes. There's a 41 and a 35. We just take 6 times the largest. Okay, and that's how we'd get this distance here. Okay, so that's kind of the long and short of how we find those out. I can kind of just touch base on these objective exercises. I would draw a picture out for these. Okay, this helps out immensely. So in this, I got basically it says we got 3 14-2s coming in there. So again, they have a bond, but we don't worry about that. So we count the ins and outs, the morettes, the device. We get a total of 9 number 14s. So I go to table 23 and find out the minimum depth based on that. Again, I kind of want to let you guys go through this stuff too. Here, again, not insulated, don't count these. So we'd have to use table 22 for this because we have different size of wires. So we count all the wires, find their milliliters from table 22, total them up. So I got 5 here, 1, 2, 3, 4, 1 for the moret. Here I got 3 going straight through, and it tells you what size they are here. And here I got splices under each wire, so I got 1, 2, 3, 4, 5, 6, 7, 8, and then 1 for these 2 morets and 1 for those 2 morets, so for a total of 10. Find out the total milliliters for each size of conduit, total it up, and you should be in business. Last example again just goes through, there is a little bit of a scenario here where we've got to get the equivalent trade size of conduit. So I found it was 21 mils based on the fact that I got 3 number 6 in there, and then had to size that uninsulated guy based on D5. I used a number 8, and it's kind of convoluted to find out that it's a number 8 or the size smaller. For tech, that's usually a rule of thumb I used in the field, was the bond is usually a size smaller than the other conductors. If you go off the wire ampacity, which I don't think you should do to size a bond based on the rules, you would get a number 8. Technically, we should be going off the overcurrent, but I think this example was done prior to the changes in section 10. Try and just go, I would say go with the rule of thumb that the bond's going to be one size smaller, and you'll be in business here. Okay. Last thing they talk about is conduit expansion and contraction. Okay, it's not too terrible because the rule is right in the appendix. So if we go to appendix B, it's not too terrible to use. I think it's appendix B. So right here, it's got all the different coefficient of linear expansion, whether it's wood, brick, steel conduit, rigid, RE conduit, concrete, aluminum conduit, PVC conduit. Okay, and it gives you a formula right here based on the different temperature swings, the length of the run, and the type of conduit it is, and it will give you the basically the length of the expected expansion or contraction. Okay, basically what they're saying, and you can also do it with a 90 too if you don't want to use a back-to-back 90, if you don't want to use an actual expansion joint. But basically what it's saying is, you know, and I'm sure you've seen the effects of this, if you've seen somebody do a long run of conduit that's exposed to a large temperature swing, it ends up buckling and twisting and looks like hell. And could potentially come apart and get water in it, all that kind of stuff too. Okay, so we do have expansion joints for that. You can kind of see the difference between cold weather and warm weather. It just allows some flexibility, okay, in that conduit run. Again, shows how you should adapt to metal too here, and then gives you a couple of example questions. Again, use that example they give you in the back to explain it. Last objective, I kind of want to let you guys go through yourself, and then you can ask me questions, because this is kind of a tally of everything. But this first example goes through this whole scenario, basically, you know, spot by spot, and will tell you exactly how you're going to size these, and then it gives you an opportunity to do it on your own here as well too. Okay, so give that a try. Obviously the answers are in the back as well too. And if you have issues with that, let me know. Okay, but that's wiring methods. A lot to go on there. But read through the mod, go through the blackboards, use the feedback, and I think you'll be in business.